But what happens to the sediment that is transported through the valleys during times of relative sea level fall and low stand? I'm sitting on a 3-metre thick sandstone in the Eastern Butt Cliffs. Below this sandstone is tens of metres of marine shale. When I look at the internal features of the unit, I see current ripples, some wave ripples and significant cross-bedding. In more detail, this sandstone is coarse-grained. In fact, it's coarser-grained than anything we've seen so far. It contains bivalve fragments and locally, as I can see here, shark's teeth. Now locally this unit forms the tops of the hills, so I can't tell what originally overlaid it. However, when I map it round to the northwest, I notice that there's at least 50 metres of marine shale directly above it. So this unit was encased in marine shale both below and above. That raises a question then, how did it get here? How was it emplaced? In order to answer that question, I'm going to meet up with John 2 kilometres to the west of here. Hi John. I've been tracing these units over 2 or 3 kilometres into this area, and I've been seeing shark-based units, evidence for rapid deposition, fairly shallow water conditions, and then capped by a marine shale. What are you seeing here?
This lower unit here contains a series of muddy heteroliths. The interbedded sandstones and mudstones include a whole series of wave and current ripples, and the mudstones include a whole series of marine biotubation, indicating these are in fact marine rocks. Above this surface here we have a 1 metre thick sandstone, which includes a whole series of soft sediment deformation and lode structures at the base of it. That implies it was emplaced pretty quickly.
So we've got a problem here. How do we emplace these volumes of sand out into the deep basin? I wonder if sequence stratigraphy can shed light on that. What I've been thinking is we've seen a lot of incised valleys at different stratigraphic levels. Now we know that incised valleys are conduits for sediment to bypass the shoreline during low stand and deposit sediment at their mouths. I wonder if these are those sorts of sediments deposited at the mouths of incised valleys during low stands.
Well, we've studied the facies in some detail, and we've certainly seen a lot of evidence for sea level rise and also sea level fall, so that sounds like a reasonable model to me.
I think we need to do more work to understand the detail of these low stand units. So, you know, although the Butt Cliffs has been a proving ground for sequence stratigraphy for some years, it's not over yet.
No, but there's a storm coming.
I know.